and that continued into this week, where we talked about we deployed services, we talked about Helm. My goodness, we did a lot.
There's a lot to do.
It's quite a bit that we can talk about. So I see Apple II Games is very excited to know what the topic is, so I don't want to keep you hanging any longer. So today, what we're going to focus on is autoscaling in EKS. And when we say autoscaling, Brent, I'm going to throw a question your way. When you think
Nice.
autoscaling in a container orchestrate, an orchestration environment of containers, what are all the places where you need to consider scaling?
Well, that's I'm glad you asked that question because it really leads us down the right road. Um, One of the cool things about containers is that you can bring them up very quickly, and you don't have to worry about configuring the environment and stuff like that. Because once you've done it once, then doing it 1,000 more times is pretty easy using an orchestrator. So, scaling the container, adding more of them is definitely one area to pay attention to and focus on. Um, but the problem is, if you scale out and add too many containers, then eventually you run out of space, you run out of compute, you run out of resources. So scaling the platform as well is another dimension that you have to look at unless you're using something like Fargate. um, so anyway, I hope that was what you had in mind for that question.
Exactly what I had in mind. A plus. So,
Sweet.
so that leads me to the workshop. So, for those of you, first of all, before we get started, if you have any questions, any comments, please throw them in the chat. Say hello. Say how amazing we are. We love all of it. So, um, but we're gonna dive into the workshop. This is eksworkshop.com, and anyone can access this. So if you want to run through this workshop on your own, please feel free. I just recommend you start with the Start the Workshop section, which, if you want to follow us, Brent led us through that last week. We have videos, which Brent will share in our chat, where you can access the videos of us walking through this. See, that's amazing. Um, so,
You and me.
so let's get into it. Okay. So as Brent said, when managing a container orchestrator, you have to consider autoscaling in a couple different places. Now, if you're using Fargate, which those of you who aren't familiar with Fargate, Fargate is essentially a way to run your containers without having to manage or even think about the underlying EC2 infrastructure, the virtual machine infrastructure. So that becomes abstracted, that's fully managed. All you have to focus on is your container and how do you scale your container, right? So that's the one metric when you're using Fargate. Now, it's not always, there's going to be cases where people don't use Fargate and you want to manage your own data plane. And when you get to that point, you now have to not only think about managing your service, right? So you deploy your container, runs in a pod. As traffic increases or as load increases, you need to scale that container, those pods horizontally to match the traffic or the request count, whatever that is. But then, as Brent said, once you hit past what you have available, you have to also consider scaling the data plane as well. So this is scaling, the EC2 instances to make sure that you have enough compute to, support the pods that are running on the cluster. So that leads us to this section here. So this is in EKSworkshop.com, and we're going to talk about two things here. We're going to talk about the Horizontal Pod Autoscaler as well as the Cluster Autoscaler. So I think those are pretty self-explanatory, but when you think of HPA, the Horizontal Pod Autoscaler, it has one job, and that job is to scale your pods in a deployment or replica set. And what that means is after you deploy your service, you'll set your scaling dimensions in your config, and that's how the autoscaler is going to know how to scale your service out and then most importantly, back in when it doesn't need to have that many instances running, that many pods running.
It might be worth mentioning horizontal and that term. Let's just define that real quick. When you're scaling horizontally, and this isn't limited to containers, this is the way Lambda works, and it's the way EC2 compute works, and stuff like that. If you make more, you're scaling horizontally. If you take what you have and make it bigger, you're scaling vertically. So horizontal auto scaling is making more of something, and then vertical auto scaling would be taking what you have and making it bigger or smaller, depending on what's appropriate. People tend to prefer horizontal auto scaling because uh, to vertically scale up and down, you have to have, you know, a good understanding of your application and how it works, because there might be a query that comes in, or a request that comes in, where you have to go hit the database, and the database is going to return you a result that's maybe a page long, and you can then process that and feed the answer back to the customer, whatever the transaction happens to look like. But the next request comes in, and your result might end up being like 1,000 pages long. And so that kind of footprint, is much bigger or much smaller. If you only hit that like 1 in a million requests, a vertical auto scaling system might have scaled you down, really low. And then all of a sudden you have this massive request come in, and you don't have enough resources in the single pod to handle that request. So, if you either A, have a very predictable sizing of your workload, then vertical pod auto scaling can be handy, or B, if you can be very, what's the right word? Very quick to react, I think, or something like that, then maybe you can scale vertically. But for the most part, most people prefer horizontal, because then they can size their pod appropriately for whatever the maximum size of an individual request should be, and then they just make more to handle more requests, over time.
Yeah, and that's a great point. And I think even so that now there is vertical pod auto scaling, that you mentioned it, that is available.
Totally.
We're not going through that here, but I think to vertically scale up and down, I think it's a little more intensive, right? It requires a service to restart. Like there's just so much more that goes into it. Whereas if you can really refine um, your compute and your resource utilization that you need, and define that when you deploy your container, horizontally scaling is very easy, right?
Yeah. And horizontally scaling also tends to map better to the type of traffic that you need. Like, for example, let's say you're running a social media site, and you're extremely popular in the United States and in, I don't know, China. So you might see traffic pattern, daytime in the United States, and then it kind of drops off until it's daytime in China. Then it picks back up, and then it drops back off until it's daytime in the United States again. So that up and down curve, you can match that, very simply by just running horizontal pod autoscaling, and have those pods increase and then decrease with your decreased traffic. So it tends to, horizontal pod autoscaling tends to match more closely with, your traffic patterns. So that's another good reason to sort of make that your default attack plan of attack.
Yeah, great point. So now that we've talked about it, let's do it.
Totally.
Let's get into it and let's deploy it. So I have an EKS cluster. It's up and running right now. I'm using Cloud9 here um, as my IDE, which if you want any information on that, check our past videos. You'll be able to see we kind of talk about Cloud9 a little bit, walk through how to set that up. So what I'm going to do first is we're going to deploy the metric server. So in order for us to scale and to determine how to scale, we need metrics to scale off of. So we're going to deploy the metric server. We're going to deploy it via Helm, which again, we talk about in the previous video. So please check out our videos if you want to get up to date or up to speed on any of these topics. And essentially what this is going to do is it's going to install the metric server for us, which out of the box will then give us, for our services, CPU and memory metrics, which we can use to scale. Now, of course, in every environment, it's completely crazy to say that CPU or memory is going to be your metric to scale everywhere, right? You could have a Kafka service, right? A consumer that's consuming from Kafka, and as your lag increases, you need to scale out. So maybe that's a metric you want to scale off of, or traffic from a load balancer, etc. Right? So there's different metrics that you can use. You can always have custom metrics, as well as you can have not just one metric, but a collection of different metrics as your scaling metric, if that makes sense. It could be
that was a lot of metrics. Yes.
A lot of metrics there. All right. So let's do it. So what are we doing here? We're doing two things. One, we're creating a namespace for the metric server. So a namespace is a way to isolate services or deployments from other services and deployments in other environments. It's just a way to logically group a service and give it kind of an isolation or services.
By the way, can you pull your terminal up a bit? I might actually be covering up your output.
Perfect. Yes, good call. Thank you for that. So I moved it up. And okay, so here's what happened. So we did a Helm install of the metric server. So again, so we have Helm is our command, the verb install, and metric server is what we're installing. So it's been deployed, and what we want to do now is we're just going to confirm that the metric server is actually up and available. Okay. So again, you can follow along in EKSworkshop.com on your own. So here we can see we've basically, this has been deployed as an API service, which is a way to deploy a native-like Kubernetes experience. So you can deploy something to Kubernetes and access it via the Kubernetes APIs. So that's what's essentially being done here. It's not a native Kubernetes out-of-the-box service, so it's something that's been deployed separately. So here we can see we're good. We have our metric servers up and running. Everything looks really great. So now we're ready to actually deploy a service. And what we're going to do is we're going to deploy a web service. Now in this example, we're simply just going to run. We're going to run a sample application. We're not actually defining like a deployment YAML or anything here. And what this will do is it's going to give us a custom image. And actually, I will show you. We have a link down here. So I can't find it. But we get this. This is just a known image to use to test scaling. So let's go ahead and deploy it now. Okay. So go ahead.
I was just going to say this image. One of the things that it does when you make a request, send it a request, it does some kind of calculation and then returns back, a response. And the only reason it's doing that is to generate some CPU load. So in effect, we're like artificially, this is taking the place of a workload that you might be running that requires, a fair amount of CPU. So, as we continue to send it more and more and more traffic, it's going to need more and more and more CPU, and therefore we're going to need to, scale out to be able to handle that traffic. And that's what the Horizontal Pod Autoscaler should do for us.
Exactly. So as we can see, I ran a kube control get service. I can see my PHP Apache service is running. Everything is terrific. So now what we need to do is we have our service, but now we need to actually associate it with the Horizontal Pod Autoscaler so we know how do we autoscale this service. So if we kind of take this command apart, we're essentially saying we want to take this deployment and we want to use CPU percentage of 50% as our desired kind of max capacity, max
Our
utilization.
threshold.
Thank you. Geez, the word was not coming to me. So our threshold, and this is why it's great to have you here, Brent. Thank you. So we have our threshold set at 50%. So if as traffic increases, so what we're going to do is artificially increase the load, the CPU load, so it's going to go way over. And then what we're saying is our minimum count of services we want to be 1, and our max count of pods is 10. So
Makes sense.
And this is good for, I would say, maybe obvious or not so obvious reasons. But of course, if I set the max threshold to 1,000 and I don't have enough infrastructure provision to match that, or I don't want to scale to meet 1,000, we can have these bounds in place, these boundaries to make sure we don't go crazy.
Exactly. Yeah, there's always the boundary of your wallet. So you never want to outscale that.
Exactly. Exactly. Okay, so we've deployed it. This may take a couple minutes, but what we're going to do here, let's clear the terminal. And, oh, perfect. Wow, that was pretty quick. So what we've done is we're doing a kube control get HPA, and this is going to return all of our any service or deployments that we have autoscaling set for. So you can see we just ran the command to enable it for our PHP Apache service. So our target is 50%, minimum pods 1, max 10, and current replicas is 1. So now we have it running. Everything's looking great. No load. This is beautiful. Now let's start to get crazy and throw some chaos.
Yeah.
I feel like this is not chaos engineering by any means, but anyways, the idea is we want to showcase how we can have some heavy load and how it will react.
Exactly.
So now I'm going to bring this down. I'm actually just thinking I'm going to close these and I'm going to just open up a tab to the side. I believe this will do it. Yes, that's what I wanted. Okay. All right, so what we're doing now is we're going to just run we're running a BusyBox image. This is just a minimalistic image, and we're running a shell inside that image. So using kube control, we're running this container in Kubernetes for us to actively run commands in and do what we need to do.
So this is going to end up being your client that you're going to send traffic from.
Exactly. Yes. Thank you.
Sweet.
And what we're going to do is just in a little loop here, we're just going to keep hitting the Apache service, that service that pod, and there we go. So now we see it's just looping over traffic and constantly hitting. So now what I want to do is while that's running, we're going to actually watch this, and I'm going to do a watch. Actually, you know what? Let's just do a -W. So as you've probably seen Brent do over the past few days is the -W or the --watch flag. So what we're doing is in real time now we're seeing load is increasing on our PHP Apache deployment, and the pod autoscaler is going to recognize, and I believe it checks every 15 seconds, that it checks the metrics, and so that's how it's able to then report back what's happening with the CPU utilization. And already you can see we've scaled up to 3 replicas. So within a pretty short period of time, the autoscaler has recognized that our service is well above target capacity, or a target threshold of 50% CPU utilization, and it's triggered a scaling event. So
That's awesome.
We'll keep an eye on this. It's going to take a few minutes to go all the way up to 10.
While it's doing that, let's point a couple things out. So we're using the metrics server. We depend on that, and HPA, Horizontal Pod Autoscaling, is reading the metric out of the metrics server. So let's talk about that for just a second. If you've ever run your own metrics service, you know that there's a lot involved, and a lot of times what you have to do is you collect metrics, you ship them off to a data store, Very often that's some kind of time series database, and then you build, sophisticated queries on that time series database. This is not that. So this is a much, much simpler approach where imagine it's just kind of an in-memory key value store where every time a metric is updated, the history of that metric is erased. So we only see the latest number when we're querying from this particular metric store. So there is no time series database. There is no notion of acceleration or a rate of change or anything like that that you might think I'm going to build a metric on how fast this, is changing. It's nothing that sophisticated, but by keeping it simple, we can keep the management of this extremely easy. So we can, do a very simple Helm install, and we don't have to worry about, storing all of this data and pruning it and managing it and compressing it and resampling it and all the things that you have to do with a time series database. So just go into it with that understanding. This is simple, but it's simple on purpose. So we're looking at a live current view of these metrics, and we have no understanding of the history of that particular metric.
That's a great point. That's a great point. So, and as we've seen while Brent was talking, you can see that the scaling has continually increased. You can see our target utilization of 50% was pretty high at 167. We scaled up. We got to 59% with 8 replicas running, and now it's scaled all the way up to 10. So what we should see now is our target our go below 50%. So we should be below our 50% target, which is good, which is the goal here, right? You want to scale to ultimately meet the demand and make sure that you can serve your customers or your whatever, you have an API, you have a contract with other services, what customers are your services. So you need to make sure that you can, meet that threshold and meet that time. So it's looking good. So we're below 50%. We've made it. And this all happened, as you can see, we triggered load, and within 4 minutes, basically within 4 minutes, the autoscaler scaled to get us below that target threshold of 50% CPU utilization.
And not only that, but I would even, I think it's worth noticing or pointing out that, every time we add a pod, that changes the load profile itself, and we have more workers that can respond to those requests, and so that kind of flattens the curve a little bit, and then we're able to like feed in more requests a little bit faster, so that raises the curve a little bit. So it's this constant ebb and flow until we eventually settle out, where we are.
Yeah.
So,
That's a great point.
yeah, so, every time we make a change, that changes the whole dynamic, and we have to then reevaluate it. And like Adam pointed out earlier, we only do this evaluation every few seconds. So, there has to be kind of this observation period in between. Otherwise, we would just be constantly up, down, up, down, up, down.
Yeah. Exactly. So that is so we're done with the application autoscaling, and it was pretty straightforward and pretty
Yeah.
simple. Like,
I mean, that's super easy.
it's kind of crazy to think about how easy that was.
Let's talk about what if this was, so this is on EC2, obviously. What if it was on Fargate? Is there any difference?
So from a scaling perspective,
Yeah, like if PHP Apache was, getting deployed to Fargate instead of EC2 instances, would we have done anything any different?
not as far as I know.
Yeah, no, it's the same.
Yeah.
So we can, the I think what we're getting to is What happens if we run out of EC2 instances? But even before we think about that, just think about the possibilities when you have your application deployed to Fargate. There is no concern over running out of resources, right? You can just keep scaling up and up and up as you need it, again, until your wallet hits capacity. And then, when you're done and that load subsides, scale down and down and down. And those containers will go away and you'll stop paying for them.
Bingo. Bingo. And, on that note, so now that we've scaled our service out, I shouldn't say we, I should say now that the pod autoscaler has scaled us out to our max pods of 10, what happens if we don't have enough EC2 infrastructure in our data plane to run those pods? So let's go into that. Let's actually talk about the Cluster Autoscaler. Because, as Brent said, if we were using Fargate, we would stop here and we'd be done.
Yeah, end of story.
But
But that's not normal. That we know you often have your data plane on EC2. So let's talk about how we scale that.
yeah, so let's get into that. Okay, so now we're going to talk about the Cluster Autoscaler. So there's a few different ways that you can use the Cluster Autoscaler. I think it's cool to note that this integration it works with the AWS Autoscaling groups. So behind the scenes, you just have to essentially, and you'll see as we set this up, we're going to connect it to an autoscaling group, and then from there we're hands off. The autoscaler will actually scale the EC2 instances out as the demand is there. So in the case here, we're just going to use one autoscaling group. Okay, so we have our data plane, our worker nodes, all basically managed within an autoscaling group. And now we're going to configure the autoscaler, the cluster autoscaler, to point to that autoscaling group. So what's nice about the workshop is we already have a file, a deployment file ready to go. So I'm going to keep this running. And I'm just going to open up this. And actually, I'm going to stop the load. I think I was told to do that in the workshop, and I didn't. So let's exit that container. And ideally, what we should see in the next few minutes is the replica count will go down because we're well below our target threshold and we don't need to be running that many pods. So keep an eye on that. We'll come back soon.
Cool.
Okay, so we've pulled down our cluster autoscaler YAML. We're going to basically just update our this YAML with some some features based on like the EKS version we're using, the Kubernetes version, and then that's how we'll determine the autoscaler version. So just some boilerplate stuff. And now we're going to go and actually modify the autoscaling group. So if you're here hanging out in this stream, I'm just going to make an assumption that you're familiar with autoscaling groups. But if you're not, in AWS with EC2, there's the concept of an autoscaling group. An autoscaling group is a way to essentially manage a desired kind of set of EC2 instances that you want running, and then what your max count of EC2 instances you want to run, and then what your minimum count of EC2 instances you want to run. And the autoscaling group can plug into a lot of different services within AWS that can manage that scaling for you, or you can actually configure your own scaling based off your own metrics to scale your autoscaling group in and out. Now, in the case of what we're doing here, who's going to manage our autoscaling, Brent?
The cluster autoscaler.
Yes. Gold star.
Yes.
So, all right. So let's go to the autoscaling group. And what we're going to do is edit two things. So when we created the cluster, we set the default. We set the default of instances to be 3. And we kind of just kept a baseline. 3 desired capacity, 3 minimum, and 3 maximum. So minimum, maximum, that's pretty self-explanatory. Desired capacity, just a cool little thing with autoscaling groups to talk about is if somehow You know, Brent went in here and he was just getting crazy and decided to kill all our EC2 instances because he was just
Done
unhappy,
that.
and it
Yep.
happens, right?
It does
And
more often than I care to admit.
but the truth is, I know Brent, and I know Brent is of the mindset of immutable infrastructure. So the idea is, even if he kills all three, the new any new instances that come up, they'll be ready to go. There's no humans needed to make sure that that comes up and that it's added to the cluster and everything works. So Brent went in, he killed those three instances. The good news is the auto scaling group's going to recognize that three instances have been terminated, and now it's time to actually spin up three instances to meet our desired capacity. So don't worry if you have a Brent out there who wants to just go and kill all your infrastructure, kill all your EC2 instances behind auto scaling group, they'll come back as long as you have the desired capacity set. I feel like don't want to be taken out of context there.
That's
So
true. Yeah, no sound biting that.
so okay, let's edit the auto scaling group. And I think we wanted to set our desired to 2. Or actually, what was our desired? Let me go back and look. We didn't change desired. Desired was 3, but I'm going to set it to 2 because I feel like it. And I'll keep it at 3. And then we're going to set our minimum instance count to 2 and our maximum instance count of 8. And again, as we've talked about before, you know, I get it. If you have all the money to spend in the world, you can set that to however high you want and just let it rain. But we don't want to do that here. So we want to make sure we have some control. So that's the idea behind this is we need to have some controls because if you have a runaway process, a runaway container that's just going nuts, you want to make sure that it doesn't go too nuts. So that's done. We've modified the auto scaling group. Now what I'm going to do is I need to grab the name of the auto scaling group because in my cluster autoscaler configuration, I'm going to add that in there. So it knows what auto scaling group to talk to. So I'm grabbing that, and I'm sure there's a copy button somewhere for that. I just prefer to do things in weird ways.
Yeah. I remember back in the day when there weren't any copy buttons.
Yep, and I think
Sounds so old.
but I think that's why I still highlight and copy things.
Totally. Yeah.
You know, Brent and I have been working in AWS itself for quite a long time, so we have some old stories and we've seen some things. Just kidding. I don't know what I'm saying.
He wasn't lying when he said I came along and deleted instances just for the hell of it.
Oh, so many good stories with that, I bet. Oh boy. All right, so we could have a stream, Brent, just on you and I talking about all the flubs we've made.
Oh man,
in our
that would be
careers.
great. Like streaming failures.
Yes, and you know we learn from them. I'm
Absolutely.
I'm fortunate. I feel lucky to say that I've worked at places where we've embraced failure, and you know it's we learn from it. You know, but hey, I've brought down production apps
Oh yeah.
unintentionally, and
I think I have a PhD in messing up.
but that's what it's all about. That's how we learn. Obviously, we learn though, and we don't do it again if we can avoid
Yes.
it. But okay, so what I did was I went into our deployment configuration, okay, for the cluster autoscaler, and I just pointed it to my autoscaling group. And you can see here we also defined our minimum and our maximum instances as well. So let's save this. And you know, as Brent said, we use Vim. So if you're using Nano, I think it would be like bang 25 characters, shift X something. I don't know. I'm not a Nano person. I struggle with Nano.
Clearly.
Okay, so okay. Anyways, I'm just kidding. Nano's great. So that's it. So we've set that up. Now, before I get into the next section, I'm already kind of teased it here, but what would happen? You know, when we talk about EC2 instances, Brent, tell me, how does an EC2 instance know, or how does an EC2 instance gain access to run certain API commands against the AWS APIs?
Well, it has to have permission to do that. So all permission boils down to something in IAM. So we have to assign it the right permission using IAM.
Exactly. So, because the EC2 instances need to talk to the autoscaling group, and when you talk to resources in AWS, it's basically it's the API call, right? It's wrapped in an SDK, um, or a CLI or whatever that is, but you need to have the permissions to do so. So the first thing we want to do is we want to make sure we have the proper role created so that we can actually, when the autoscaler runs, it's going to run the commands we expect. So we've already created this role, which is good. So we have a role that we can assign to the nodes in the node group. And it's already set. But as you can see here, this is a snippet of the IAM policy, which gives those instances access to run against autoscaling, against the autoscaling API. It can describe the groups, describe the instances, set capacity, terminate instances via the autoscaling group, and then describe tags. Kubernetes is big on tags.
So it's important, I think, to notice this is a, let's take a look at this from a security perspective real quick. Everything that we're doing here is reading, with the one exception of terminating instances. However, the terminating instances is still limited to instances that are part of the autoscale group. So this thing can't come along and wipe out, the rest of your infrastructure or anything like that. It has its one autoscale group that it gets control of, and that's what it gets to be able to terminate instances in. And this is a level of trust that we need to be willing to grant to this service. This is what we're asking it to do.
Yep. And with so by default, when you create a resource in AWS, that resource doesn't have any permission. It's we talk about least privilege, security. So when you create these instances, these EC2 instances, they don't by default have any access to do anything against AWS APIs. So we need to be able to assign that level of access to those nodes. And as you can see, it's pretty limited in scope. So the idea is we always want to limit scope as much as possible. Okay, so let's validate that this policy is actually attached to the role. It's not. So I need to take this policy and I'm going to attach it to our role that is assigned to our EC2 instances in our node group. And that's done. So now let's confirm that, because I ran the confirm earlier. There we go. So what I did was I got the role policy. I wanted to see, does this role contain this policy that I'm looking for? And it does. So on that note, we're ready to go and actually deploy our Cluster Autoscaler. So let's do that. And by the way, Brent, for extra credit points, if I were to deploy a service in EKS and I didn't want to assign a role to my EC2 instance, is there something I could do to even limit the scope even more?
Yes, and you point out a shortcoming in the workshop right now. So URSA is IAM roles for service accounts, I think is what it stands for. And we can actually assign a role to a specific uh, pod or service instead of to the whole EC2 instance. This chapter was written prior to that being a feature. And so we still assign the policy to the instances. However, it would be a terrific update if we instead change this chapter to assign it to the cluster autoscaling service instead. By the way, it's worth pointing out EKS Workshop is open source. And so you can actually follow a link on the left menu bar to get to the GitHub repo, and you can propose edits yourself. There's also an edit this page in the upper right hand corner of every single page. And so if any of you guys want to contribute that particular change or any others, definitely feel free. Adam and I are both, like on the, let's call it review committee for lack of a better term, for reviewing pull requests. So definitely propose any changes that you see, and no matter how big or small, we'll check them out and get them merged in. So we have, I think, over 150 contributors at this point who have contributed something to EKS Workshop.
That's pretty amazing. Yeah, that's the beauty of open source. Um,
Yeah.
so while Brent was talking there, we deployed the Cluster Autoscaler, and we can see that the Cluster Autoscaler is running. It's checking against current nodes. You can see it's checking CPU utilization on those nodes, and it's looking for any instances that it needs to scale down. It's basically running all the logic that it needs to run to confirm, are we at a count of EC2 instances that's acceptable, and can we scale down, or do we need to scale up? So these are just the system logs we reviewed, and we were able to see the logs for the deployment. Now, let's actually do some auto scaling.
Yes.
Okay, so we're going to deploy a sample application, Nginx, and so we're going to deploy it. We're going to start with one replica. So let's get that going. Okay, and so I've deployed the replica. It's already up and running, so we're good to go. Okay. Now what I want to do is I want to scale this out. And by scaling it out, what should happen is we should see, and actually, we may have, I may need to scale it out to something even bigger because, yeah. So remember earlier, our PHP Apache service, I had stopped the load generation. So a few minutes later, it went from 10, because you could see the target percentage was the actual percentage was well below our target percentage of utilization. So it eventually scaled back down to 1. So, but actually you can see here, so we have 9 out of 10 services ready to go. So what does that mean? That means 9 have been deployed, but we have 1 that's still waiting because there's not enough resources to schedule that last remaining pod, that replica. So now in our example here, we had quite a few more. So I feel like I should scale it out more just to be more aggressive.
Yeah, why not? What could it hurt?
Yeah, that's what I say. So let's do that. So, okay. So it's scaled out. We now should have all 10. Let's confirm. Yep. So all 10. And let's see, we had 3 instances. And you can see here in our Autoscaling group, if you can see the number, before I refreshed, it was at 3. Now it's jumped to 4. So if you look at activity history, you can see that it triggered a launching of a new instance. And by the way, earlier, this was earlier actually. But anyways, so it triggered the autoscaling event to make sure that we had enough in our data plane to run our pods.
So I guess what I see with this is you have Cluster Autoscaler that's actively looking at the sizing of the pod, the resource and as it relates to the threshold that you set, and then it adds more. But it's not until it can't add more, or it's not until any kind of deploy comes along that can't add, that can't complete, where there's just something sitting there waiting to, on a resource to be available. That's when Cluster Autoscaler kicks in, right? So it's not doing anything fancy, looking at memory sizing or anything like that. It's really just looking at, is there a deploy underway that can't complete?
Yep. And as a matter of fact, so while you're talking, like just like that, I scaled to 20, and I was watching the Autoscaling group, so we were able to go from basically 10 to 12, but then we couldn't schedule 8 replicas because there wasn't enough resources. So you see the Autoscaling group launched 3 more EC2 instances, and then what we should see shortly is our pods being scheduled onto those instances as they come up.
Nice.
And we could even, let's see here. Let's go here. And let's see if we can catch the auto scaling event. I was a little behind there, but I'm looking at the cluster autoscale logs. You can see the scaling event. It's somewhere there. It's hard to read.
It's there.
It's there though. I hate to say that. It's hard to read, and the font's so big. It makes it a little harder. But anyways, basically in the cluster autoscaler logs, we see there are, oh, here you go, perfect. This is so 5 other pods marked as unschedulable that can be scheduled. So that was what Brent was talking about, where it's waiting, that it's then recognizes, hey, there's pods that can't be scheduled. Do we need to take action? Yes, we do. And as you can see, now we've met our count of 20. So
awesome.
That's pretty awesome. And that's basically it. So you go here, we see in our autoscaling group we're at 7. What I'll do now is I'm going to scale these back down to, I'm going to scale it to 1. And that's it. We're down to 1. So now we can watch the logs, but this may take a little while as we scale in. But the idea is, again, scaling out is very important, but almost equally as important is scaling in to make sure that you don't have idle resources just sitting around doing nothing. You don't want to pay for things you're not using. So
exactly. That's awesome.
So
I mean, are there any questions you guys want to toss at us in the chat? And while we're waiting on that, let's just review real quick what we did here. So we talked about there's 2 different dimensions that you'll probably want to think about when you think about autoscaling. One is your pods, scaling those out and back in. And then 2 is your EC2 or your compute or your data plane, the resources, scaling that out and back in. We mentioned Fargate. If you are a Fargate user, you don't have to think about that second dimension, that data plane scaling out and in, because Fargate just eliminates that as a need. It is the data plane, and it is perfectly sized to match. As you add a container, it adds capacity. As you remove a container, that capacity goes away. And then we talked about the permissions model that you need to grant for the cluster autoscaler, and how the cluster autoscaler doesn't pay attention to any kind of metric service or anything. It's simply looking for pods that you're trying to schedule that aren't able to be scheduled because of a lack of resources.
Yep, I was just posting
Yeah.
the image we used. So there was a question about the command we used to trigger the load on this service. We actually just used a container, an image that was already pre-built for this. You basically say on every request, how do we want to basically enable load on that container. So we just were running a simple, I think it was a simple curl, a wget, but it essentially just hitting that endpoint, and every time we hit that endpoint, it was increasing the load because the service itself was a service designed to trigger auto scaling.
Yeah, that service is doing a complex calculation that requires CPU, and so by hitting it so frequently, so fast, we're increasing our CPU utilization.
Yeah, and in ECS Workshop, we do some load testing, and we use a tool called Siege there. So
yeah, if we were to point Siege at this, we would have like gone straight to 10 and just sat there. So
yeah,
you probably could have set your maximum threshold to 100, and we would have hit 100 with this particular PHP app.
Yeah.
So yeah, you want to be careful how you load test things and try and be realistic. And this particular application is designed to sort of emulate something that is, that requires higher CPU than a typical API or something like that.
Yeah, exactly. And that's why we were ultimately able to get to that 10 count and get below. We were able to figure out the math to do that.
Yeah.
So that's pretty much it. I mean, it's pretty cool that within the basically the span of 45 minutes, we deployed a sample application. We enabled the pod autoscaler for cluster autoscaling and pod autoscaling, and we got to just test it in real time. I mean, this is why one of the reasons why I think EKS Workshop and ECS Workshop are so awesome. I said this to you before, Brent. I think I even said it on the stream a week ago, but oftentimes when there's a question I have about EKS or if there's something I'm trying to do, I go to EKS Workshop first because there's a good chance that scenario is covered here, and I can just take what's done there and do it on my own and figure it out. So it's very helpful in getting that hands-on experience.
Yeah, exactly. And sometimes you want to get really academic and understand like how something works and that kind of thing, but then other times you just want to see a practical example. And then you can like take that practical example and bend it a little bit and fit it to your particular use case. And I think that's what you find more often than not on EKS Workshop. It's a whole bunch of practical examples of us doing whatever the topic happens to be, in this case, auto scaling. And we do that, in the chapter. And then you can take that and you can apply it to your own pods and your own infrastructure and your own auto scale groups.
Exactly. Exactly. So, as Brent mentioned, you can follow us on Twitter. So generally, we'll post, when we're coming on, if we're not coming on the stream. But this is going to be a regularly occurring stream. Regular occurring stream. I don't know.
We'll be here all the time.
Except Fridays, Monday through
That's
Thursday.
right. That's right.
And the occasional when someone else's stream needs to stream, and we'll have to step aside. But if there's anything that you folks are interested in hearing about, or you want us to cover in any of these streams, please reach out to us on Twitter. Shoot us a note. We're glad to talk about it and dive into any of these areas. But yeah, so I think that's it for today. One thing to note is that sometimes we'll talk EKS, sometimes we'll talk ECS, other times we'll talk ECR or app mesh. So this is not just tied to one particular orchestrator or container orchestrator. We may talk about other services in the container world.
Are you going to talk about something ECS tomorrow?
Yes. Which one was that? I already forgot. There's so much going
Uh,
on.
I forgot to. We had a list.
Yeah. So
We'll go back. We'll review.
we're,
In the meantime, if you out there, have a hot topic you want us to address from the container space, send it our way. We'll do our best. So thanks for joining. We really appreciate everyone's time, and we won't take up any more of it.
cool. Thanks, everybody. We'll see you tomorrow.